Hey everyone, Endgame here. Welcome to another video. Today's video is much anticipated by some of those of you who follow me on Twitter. We're going to be talking about the Windows 10 local privilege escalation. Full disclaimer, this exploit was not written by me. This research was not done by me to find this vulnerability. All of that credit goes to SandboxEscaper. I had nothing to do with any of it. I'm just simply trying to help better engage and educate the community around this exploit since it dropped recently. And I spent a couple nights staying up real late trying to learn about how it works. So I'm going to hopefully be able to share that knowledge and pass it on. My goal here today is to show how this applies in a practical scenario. Say if you're on a pen test or you were doing maybe hack the box or something like that, how you could actually use this to escalate privileges rather than just popping a notepad per the PoC. So basically we're going to adapt the PoC to pop a shell. And I also said that I had full AV bypass, and that's true except for today when I tested it out. The only thing that still doesn't bypass AV is SEP, or Semantic Endpoint Protection. For those of you who aren't familiar, SEP does have a valid signature now for the DLL injector. That was the precompiled binary included with the original public exploit code. Originally, you could just change the name, and I had changed it to yeet.exe just to be funny. And now SEP is actually detecting the signature, not just a weird quote-unquote malicious name like it was before. However, everything else that I used to bypass AV still holds up. The Merlin payloads or the Merlin agents still bypass AV. And the custom DLL that we'll be injecting still bypasses AV because that's going to have a custom signature almost every time unless you guys copy my exact code and then reuse it there out in the wild, in which case you have to come up with new fancy ways to obfuscate your DLL that you're going to inject. But that's neither here nor there. That's going to be part of the fun. So yeah, let's get right into it. This is a pretty well documented exploit. You probably don't even need to watch this video to get an understanding of this exploit. I'm going to do my best to explain it at a very high level. I'm sorry if I butcher it. If you feel like I misexplained anything or didn't go into enough detail, instead of just telling me I'm wrong or I'm stupid, tell me I'm wrong and I'm stupid, and then tell me what the actual definition is so we can all learn from it. I understand if you want to insult me. I don't care. But definitely engage us all, anybody who's reading the comments, and tell us what the actual answer is or what the actual explanations and stuff is so we can learn. You know, don't just be an asshole. I'm doing my best here. This is fairly new. I've never done anything like that. That's why I say that disclaimer. I want this to be a positive learning experience for everyone. So basically what this exploit allows us to do is there's a vulnerability in Task Scheduler that lets us set an arbitrary DACL. Now, I'm going to reference some Microsoft documentation real quick, but a DACL is a discretionary access control list. Now, this means that the DACL will identify trustees that are allowed or denied access to a secureable object, and when that process tries to access a secureable object, the system will check the object's DACL to determine whether to grant access to it. So what we're able to do is set an arbitrary DACL, which sets the security rights to a file without impersonating it. So that means a non-admin, in our case, this works in our favor because a non-admin or even a guest user is able to write to a place they weren't originally able to write because they now have permissions via the DACL. So you can read more about that. I'll post up the Microsoft documentation that reference all the access control list descriptions and stuff like that. But basically, what we're going to do is make a hard link to a DLL file that has the original DLL will have access control as NT authority system and full file system write access. So we're able to make a hard link of our DLL against that file, and rather than impersonating the DLL, we're literally running our DLL instead. So then we'll have then it'll, you know, basically essentially it'll run as root. That's the simplest way to explain it. So I'm going to dive into some of the source code here that explains exactly how it's working. So in the main function, we are using the print spooler service, and this is a pretty good service to target because it meets our criteria. Remember, the criteria is that it runs a system and it has full system write access or full file write access. And it just so happens that the print spooler service meets those two criteria. In the original source code and in the Git repo that I'll have posted, there's a PowerShell script that actually enumerates all of the, I believe it enumerates over just the services. It may enumerate over everything that has those two criteria being met. And it's a lot of stuff. You don't have to use the print spooler, but the exploit's pre-written to use the print spooler, and it's pretty guaranteed because out of the box when you install Windows 10, as of right now, the print spooler service is still vulnerable and is just on. So it's pretty reliable in terms of being able to hard link against an overwrite. So we're going to basically make a hard link against the print config DLL and inject what we'll do is inject our DLL into a process that we have read access over. So we'll run a notepad or something like that. In our case, we will have like a notepad running, and we're going to say, hey, inject DLL into this notepad, and our DLL, which is actually this code here. So this code that we're looking at is going to generate a DLL that's going to inject in the process, and it creates the hard link for itself in the task scheduler, and will then run our exploit. So for now, it has to be named the ALPC task LPE. We could rename this here and call it whatever we want, but we'll keep it by default for now just to explain it. But if you did want to rename anything to have a less conspicuous DLL name or anything like that, you could start there. And there's a couple other things you'd want to rename as well. But the meat and potatoes here, as I call it, is you can do this with any DLL that meets the vulnerability criteria, but then you have to figure out how to restart the service so that task scheduler will pick it up and run with it. That's the hard part. So I found one thing that my buddy RK Ultra and I are going to try to do after this, whenever we have some time, is we found a vulnerable scan service from SEP, and I think somebody else on Twitter has found this too. It's pretty funny, and there may be a couple of them. But just for the lulz, it's not like we're doing anything amazing. It's pretty trivial. For the lulz, we'd like to privesc using the antivirus, right? Be kind of fun. So I think SEP has a scan job that runs with those two permission set, running as system and has full file system write access. And if we could step over that to gain root, that would be fun. So the issue with that is we know what the DLL is, and we know what we have to rewrite here. It's pretty trivial. You just replace some of these path items, and you hard link against that. That part's easy. Then we have to figure out how to make task scheduler rerun the scan service. So we have to kill the scan service somehow and hopefully make it restart. Don't really know. That's kind of shaky from service to service, but in the case of the print spooler, we just need to start an XPS print job to load the DLL. For the semantic import protection scanner, we may just need to start a scan. It could be as simple as that, right? And I'm sure it's pretty easy to do that via this C code here, but that's neither here nor there. That's just an example of one of the items. We're just having fun for research purposes. It's nothing extravagant. If it was, I probably wouldn't have told you, but just fun stuff like that. That's how easy this is to take advantage of any job. And like I said, there is more than just print spooler service. So if you're wanting to be more elusive or just maybe more creative, you could take over a different DLL, or I guess a different service. You're not necessarily taking over there. You take over a different service and use that as your stepping stone to get root. So there you go. That's a high-level overview of this chunk of code that we're looking at here now. And like I said, it's very well documented. There was a doc file that included some more in-depth information, and the code is very well commented as well. And there's also a video that shows the PoC and how to use it. So we're going to dive right in. So we are set up with a Merlin stager here. So our scenario is that we already have a user on the box, and the user that we're going to already have, we have planted a Merlin agent on there, and we're going to try to do everything from our C2. So this is basically, you've sent a malicious document and to someone, or however you want to phrase it, to have compromised the host, and there's our agent checking in there now. So you've compromised the host, and you have user on that host. So that's where we're starting. And now from here, we're going to learn about the system, and or here we've learned about the system. We know it's a Windows 10 box, and we've already dropped our PrivEsc payload. So we have our DLL injector and a malicious DLL that we'll go over here shortly. So we've got that going for us, and we'll dive into that in just a second. So before we dive into that, I want to talk about what our custom DLL is doing. So actually, let's go ahead and interact with our agent. So we'll say info. So see, we're Mr. Testy, we're on Windows 64-bit, and we can say, show you guys we do have actual C2 over this. So we'll say, who are we? And then I even want to get a more specific sysinfo, and I'm going to show you guys some stuff I just learned about Merlin. So I was wondering if you ever execute a command on Merlin, like, see, we did cmd who am I, and it was fine. But sometimes you'll execute something like, say, dir, and it'll be like, dir's not in the path, and then you're kind of confused, be like, why the hell isn't dir in the path? It's because I don't think Merlin is executing commands from like a cmd prompt. Not really sure how Merlin is going about executing commands, to be honest, but what you can do, circumvent that, is run cmd.exe with the /c flag and do something like, say, a sysinfo. Oops. I don't think sysinfo is like actually a thing. I think I'm thinking too deep into Metasploit. Anyway, the point is you can execute other commands. So if I did want to do like a dir, this is probably a better example in the first place. Yeah, there we go. So we can see we're currently in the downloads directory. And I take that relatively anyway. Our agent was launched from the downloads directory because, say, we got him to download a malicious file and execute it from there. But whenever you're executing commands in Merlin, just to be safe, I always use like an absolute path, and you'll see that here shortly as well. All right, so we're going to kind of pivot over to our custom DLL. So if you've never written a DLL in Windows, this is really, really simple. It's a lot simpler than you would think. If you have written a DLL, you're about to see how trivial what I was talking about is to make this kind of work. So the way the exploit works, and we'll reference back to the exploit code in just a second here, is that there is included with the public exploit code, there is an exploit.dll file. And basically that DLL file is closed source, but when you run it on a system, it seems to just execute a notepad as the process, which runs as system. So now you have a notepad running as with system privileges. So instead, we want to write our own DLL that will give us a shell instead of just popping notepad, right? So PowerShell.exe, new object, blah, blah, blah. So this is like a PowerShell one-liner to download files. It's kind of like a wget. Basically, all we're doing is I have opened up Visual Studio. I've said make a new C++ project to write a DLL. I've selected those configurations. It gives me this. Then there's a DLL main C++ file, which gives you a DLL main function, and import the standard, or include the standard libraries. And now I can just make syscalls. It's really that simple. Now from here, you can do anything you want to do. You could run, say you wanted to not do a reverse shellback, but you want to do like a local, like a truly local PrivEsc. Now you could be like, all right, net user, make me an admin /adgo, or maybe change the password of the admin user, or whatever you want to do, and then just log in from there. So you can execute system commands as, well, into the authority system from your DLL here. So that's, the world is your oyster at that point. This is how easy it is to get pull off this exploit. So what we're doing is we're electing to call PowerShell.exe to do a web client download file for one of our Merlin agents. And this is just to ensure, we already know there's an agent on the box, but this is to ensure that it's fetching a fresh agent, and that, you know, even if the users deleted something or deleted our agent or whatever, we'll be able to get one back on there. And then it's just going to execute the agent. And since it's running a system, it's going to end up executing that agent as system. So what we'll do after you make all this is you just build the solution, I'll just build it just for posterity purposes. And you'll get a, didn't mean to close that, but you'll get a DLL file. And basically now what you want to do is you want to copy that DLL file really anywhere. You can put it anywhere you want. You can leave it where it's at. Doesn't really matter. The important part is we'll open up the Prevest source code. So the important part is in the resource RC, there is a line that pulls in your DLL. And originally this is going to be like blah, blah, blah location slash blah, blah, blah resource slash exploit.dll. And so what you're going to want to do is whatever DLL you want, you're going to want to put the path to that DLL here. In our case, I've already got a copy of that DLL in there, and I just put it in the resource folder inside the project folder. So to make that a little less confusing, that looks like this. So I've got the project folder, and then I made a resource folder, and I pasted that in, and I renamed the DLL1.dll to exploit.dll. Then in here, I put a path, make sure to back double escape, and now that's going to include it as one of our resources. That's the actual payload that's going to go in. So the main exploit that does all the hard link stuff is this source code. But then this source code will hard link, there's a hard link.c++ file that pulls in your DLL that you've included. Kind of skip through all over that. I'm not really going to go over all this. You can read it for yourself. But essentially, actually, I think this is just hard linking the DLLs together. I don't think that's actually pulling it in. I believe the DLL main is what's pulling it in. Create thread, export thread. That's just starting the thread. I beg to differ. I don't honestly know what's happening, and I don't want to butcher this any more than I already have. But the point is, that's the path that you would include your custom exploit code in. And if you want to trace that down, you know what data file or what this is being referenced as. It's pretty easy and pretty self-explanatory. I'm just not really great with DLLs and stuff like that on Windows. I'm just okay at C++ to begin with. I don't write it near as much as I used to. So anyway, enough making excuses for me. That's where you include your custom payload, and it's all fine and dandy from there. Right, so we're going to come back over here to our C2. And you'll notice that we have already uploaded our custom DLL and the DLL injector that we're going to use. So now it's really this simple. So we're already in our C2. We've uploaded this. And there's several ways we could have gotten on this box if you really want to be super thorough. Merlin itself has an upload functionality where you can just say upload my file. And here, I'll even do it for you real quick. Just so you know that, because this is how I actually did this. So if I say, echo upload worked to, we'll write this to here, and we'll call it hello.txt. I know some people just like to see the thoroughness of it. We're not going to re-upload all the binaries and payloads and stuff, though. Alright, so we'll say, what do we call that? Hello.txt. Hello.txt, and we'll write this to C:\users Mr. Testy downloads hello.txt, and we'll wait for that job to come in. Okay, that's super weird. Not sure why that didn't work. Let's fix that real quick, because that really bothers me. So we'll do this. And get our PWD here. remove the hello.txt. Let's edit this. I think Merlin just likes absolute pass, so that's what I was kind of talking about before. So hello.txt. So we'll try this again. Alternatively, what you could do is just stand up a web server, kind of like we have over here. That's going to be where we fetch our agent from. And you could just do that PowerShell kind of wget thing and pull them over. That's another great thing I do. That's usually what I do because sometimes you'll get like a janky interpreter shell back and uploads being weird. Sometimes weird stuff will happen with Merlin. But see, now we had a successful file upload, so now we can be like, all right, dir, I want to see that file. And let's even take one step further. We'll say type // users Mr. Testy downloads hello.txt, and I'll kick off that job. So there's our dir job. We can see where the agent uploaded, and then just a few seconds later we'll get the type output back, which will actually display what the stuff's in the file. So this is more of a Merlin lesson than it is as part of the exploit. So I'm just kind of trying to proof of concept how you would go about doing this. So you would upload your PrivS DLL that has the custom DLL kind of bundled in with it that you're going to inject into the process. Then of course you'd upload the DLL injector, and the agent.exe is already on there. So you can see we got upload work back, and it's working great. So now we can do the actual PrivS. So if we say cmd.exe, and we say // users Mr. Testy downloads, and inject dll.exe. Oh crap, we're missing a crucial point in this. So we need to identify a process that's going to kind of be our stepping stone, so to speak. So in order to do that, we need to do task list, so we can get a PID. And execute that. And then we need to see if there's a process that we can just kind of jump off of. Hopefully somebody maybe has a notepad open, or in fact there is a notepad open, so we have this PID here. So now we can kind of do what we were doing before. So we can say inject dll.exe, that PID, and then we want to Mr. Testy downloads, and then we want to reference our ALPC. Oh god, I wish there was autocomplete here. Task edge. Having to look over to another screen where I've got the name of it pulled up. Alright, task edge LP.el. Alright, now when we execute this should kick off our PrivS task, and then not even a few seconds later we'll see a stager come in. So we can kind of watch the separate stages of this, so we can, oops. Didn't mean to do that. Not really sure what happened there. Hopefully it works as intended. Alright, we'll watch this for a second. If we get a hit, that means we know my little screw up worked. Or it worked even with my little screw up. Otherwise, I'll try to rerun that because that was kind of weird. I accidentally hit the wrong button I shouldn't have hit. Let me just check. Make sure we still got command execution. I may have hit like I think I hit like a window D or something like that, and had some issues. Okay, there we go. So that is working correctly. So let's try this again without all the crazy shenanigans. So now we should see, we'll get a hit on the HTTP server once that job finishes. If it finishes correctly. We'll just watch the Merlin prompt to see when it checks in. Just trying to show you each stage, but okay, we're having some really strange issues here. Oh, I see what's happening. We included our type command, so it's actually typing all of that out in the display output. That's silly. I'm going to keep that in there as a blooper for you guys. There you go. So now we should actually be able to see the several stages in this, since it's going to execute correctly. Right, so should see a hit here in any second. Oh, it's going to make me kind of hit enter on this first. Okay, so checking back in on this, it seems like it did work, but we had a crashing issue on the other side. So we're going to kind of backtrack on everything we did there. So we want another task list to execute to make sure we have our process ID that we can hop onto. All right, so we got a notepad.exe here running with the PID of 11,460. And we can step on that and hopefully that'll work. So we should get a hit here. No hit. Alright, so we seem to be somewhat working, but having some issues. Okay, my apologies everyone. For some reason, the print spooler wasn't even running. And I think I had killed it from some of my previous testing and forgot to restart it. So it should be running now. It was actually, the reason that wasn't working at all is because it was impossible for us to hard link against that process because it wasn't there. So if that makes sense. We didn't crash it or anything, it just wasn't running. So we're going to get a task list back here to get another PID for another notepad. And hopefully this time it should work great. So notepad.exe now is running with the PID of, and see now we have a spool SVE.exe that we didn't have before. So 10.920. Now that should work great. We'll come back over here to the web server. Should see a hit. As long as we see a hit, that should mean that we also got the Merlin agent callback. Should be pretty good to go. Yep, there's our hit. And any second we should get a check-in from Merlin agent. There we go, receive new agent. So now agent list, and we see we have one running as NT authority system, and that's with the ID that we just checked in as. Double check that here, if I can highlight correctly. And then of course we have the agent we've already been working with. And now we have a system shell, essentially. So we can now interact with that. We can say cmd who am I? If we can spell who am I? And we can do a lot of other fun stuff like list directories that we normally wouldn't be able to list. Say, I don't know, cmd.exe dir c:\/ Windows system 32 or something. Just cuz. So there's our back, shows that we are indeed NT authority system. And our callback for further proof to show that we can list out the system32 directory should be anytime like now. There we go. And there we go. We're successfully able to list that directory. So like I said, I'll show you guys over on the other view here kind of what I've got going on as far as the antivirus and stuff is concerned. So I want to show you guys the whitelist that I had to use. And I also want to show you guys that it is indeed enabled otherwise, that it's not whitelisting anything else. No other controls are in place. So I'm logged in as the admin here. I'm going to open up semantic endpoint protection. It is fully enabled, fully protected. The only setting that I have changed here is in exceptions. So I've ignored all of Mr. Testy and all of Windows Sec. So Windows Sec is actually the admin here. If you guys are familiar with my exploit development box, it's like a Vagrant image out there that you can go grab. It's got IDA-freeware, immunity debugger, Python preset up in the path, just some stuff to make exploit development set up quicker for Windows machines. It doesn't have SEP installed, don't worry, although you may have to disable Windows Defender. Fun fact, every time I've restarted after disabling Windows Defender, it re-enables at least the base AV detection, so just keep that in mind whenever you reboot, if you're working on exploits or working with known malicious code. Anyway, so the only things I've excluded here are the downloads folder of each user. So Mr. Testy was our basic user account that we just professed from. That way I can actually work on the exploit code and not get stuff purged. So the only thing that was really protecting us from was the inject DLL.exe. Everything else was fully bypassed. It would not trigger on the custom DLL that we injected, and it does not trigger on the Merlin agent. So those are important, and I can even demonstrate that here. If I go back over to Mr. Testy, just to prove to you guys. So if I were to, here's a already proof I have this APLC task as that's another custom DLL from other testing that I've done. If I go to my downloads folder where everything is kind of just out there, if I drag, well sure we'll place it, we don't need it. If I drag the agent and I drag the ALPC, and even if I go actually open SEP to make it look for stuff, it's not gonna, both of those are not triggered by AV, completely bypasses that. However, if I were to drag the inject DLL out there, which I don't necessarily want to do, but if I were to, it would absolutely obliterate it. So yeah, so mostly AV bypass. It's like I said, I don't want to mislead anyone. It's not as awesome as it was when I posted on Twitter, and even then, it really wasn't that awesome to begin with. You can see here from this little video that everything I did was super trivial, but I hope it really helped understand how the exploit works and understand how you can apply this practically and how easy it is to practically apply this to an actual pen test or any other research that you're doing security-wise. So yeah, hopefully I didn't butcher this. Hopefully that was fun for everybody. Thank you for waiting on all my videos. I know an OSCP journey video should drop pretty much alongside this one. I haven't had an office for a little bit, so it's kind of hard to record videos on my knees in my bedroom against the bedside table. It's very uncomfortable. I don't like to do it, and I was trying to wait until I had a better mic setup. The iPhone mic with headphones is kind of working a lot better, but I have an actual nice mic setup that I wanted to start using. So hopefully my desk, by the time I publish this video, that means my desk are in, because I'm waiting to set my office space up with the video editing rig in there. So I'm not publishing these until that's set up. So that means once these are published, that's set up, which means more frequent videos, hopefully. So thank you guys for bearing with me. I know this one was nice and anticipated. A lot of people that I didn't know like this tweet, and yeah, so I just wanted to make sure I deliver, even if it was something I felt was trivial. This is something I learned a lot playing around with, and I hope I was able to share that knowledge with the community. So yeah, thanks for watching, everyone. Stay tuned for more videos.